Assalamualaikum and good morning everyone. Today, our group will present a bioscience problem in Malaysia related to agriculture and crop growth analysis using derivative. In Malaysia, one of the challenges in agrotechnology is understanding the growth rates of crop accurately. Farmer and researchers need to know not only the crop weight or size, but also how fast the growth changes over time. Using derivative in calculus, we can analyze the rate of growth and identify the best period for crop management and harvesting. This helps improve productivity and support precision agriculture in Malaysia. That's all for me. Now I would like to pass to my friend.
Okay, thank you. Hi everyone, and thank you for being here. My name is FAZIRAH. Today I am incredibly excited to present my live web page, the Malaysian Precision Agriculture Engine B3.8, which I developed under my Smart Agrotech framework. The bioscience problem my project focus on is the highly unpredictable and complex developmental kinetics of premium agriculture crop, specifically the Musang King durian. Traditionally, understanding fruit maturity and growth rate has relied on qualitative guesswork, visual inspection, or rigid historical timelines. However, fruit growth is a dynamic biological process that changes constantly based on environmental variables. Without precise data, it is incredibly difficult to know the exact metabolic and physical growth rate of the fruit as it develops on tree. Why is the studying development kinetics so critical? In the modern agro-industry, predictability equals equality and profitability. If we cannot accurately map fruit growth, farmer face major issue like they might miscalculate harvesting with expensive fertilizer by applying them at the wrong developmental stage or over irrigate, which damage fruit quality. By studying this growth kinetics mathematically, we can transform agriculture from a game of change into a highly predictable smart science. So, to solve this problem, I built this interactive stimulator. Let me walk you through how it works. So first, my website display the ecosystem telemetry is constantly track localized environmental variables. Right now, the dashboard show a solar flux of 742 W per M driving photosynthesis, a relative humidity of 84.2%, regulating transpiration, and an optimum soil NPK status showing ideal micronutrient level. So, my website processed this telemetry through a cubic growth model FT across a domain of 30 to 110 days after full bloom. To find the exact speed of development, I apply foundation calculus, specifically the first derivative WT, while the standard cubic model only tells us the weight, but the first derivative tells us the instantaneous growth velocity. So right now, this system made uh, the fruit in the lag phase. So lag phase where the cell divide rapidly but physical mass increases slowly. This will be followed by the peak max phase, and finally is a kinetic capacity. User can actually click along the curve grid vector on my interactive grow kinetic array to map this instant rate in real time. Finally, the ecosystem telemetry output breaks everything down into three clean vectors. The first one is temporary vector, second calculated mass in gram, and the WT growth velocity. So to conclude why this web page is fully functional, I have a clear recommendation to make the HTML structure better. Right now, the telemetry data and the interactive curve grids are rendered statically. To improve user accessibility and performance, I recommend integrating HTML5 WebSocket alongside dynamic JavaScript charting library like Chart.js. So this would allow the HTML elements to update asynchronously and streamline IoT data from Orchid instantly without needing a page refresh, making the interface completely real time. So that's all about my website. Thank you so much for your time. And
I'm Muhammad Fahmi bin Muhammad Fitri. Today, I will present about application of derivative in oil palm FFB grow rate. In our app, you can see the bioscience problem. The title is Grow Dynamic of Elias Luinesis. For example, in Malaysia, oil palm cultivation have maximized the crude palm oil (CPO). Fresh fruit bunches is critical for food security and export economies. A bunch physical weight and oil concentration follow a sigmoid biological curve over a developmental period of approximately 116 days after pollination, day after pathogenesis. Understanding simply the weight at any point is insufficient for high yield operation. Agronomists must monitor the growth rate. The first relative Fx, this represents how many kilograms of biomass or oil the bunch accumulated per single day. We have the mathematical logistic model and its derivative. Biological systems with limited resource are mathematically modeled using the logistic ground function. Let Fx represent the weight of a single FFB in kilogram as a function of time as in day after application. Logistic growth model. Branch width curve Fx. L. Asymptotic maximum weight of FFB kilogram at maturity. K. Growth rate convention determine speed of rise. X. Inflation point day of activity where bunch gain weight faster. Calculus derivative rate of change. Instantaneous growth rate Fx. Divide via the chain and quick rule. Provide the exact velocity of ground growth. Per day x in kilogram per day. Pure growth velocity occur exactly at the inflection point x. With interactive dynamic simulation can calculate here. Biological process breakdown. With linear stage maximum biomass and moisture import. We are the center of the sigmoid curve around the inflection point. Today, the growth speed is at near its biological limit, 0.37 375 kilogram per day. The value of the derivative Fs in precision pump agriculture have three. The first one is fertilizer timing optimizer, harvest yield forecasting, and labor and logistics schedule. That's all from me.
Okay, Assalamualaikum and good night everyone. My name is AIZAT bin MANSOR and my project title is MD2 Pineapple Growth and Derivative Simulator. This project demonstrates how first order derivative and fruit weight can be applied in agrotechnology and bioscience to analyze pineapple fruit growth in Malaysia. Uh, the first of this project is MD2 pineapple or Ananas commerces, which is one of Malaysia's important agricultural export product. The to pineapples fruit in Johor from flowering stage, also called anthesis, until harvest, which take around 22 weeks. The main bioscience problem here is that farmer do not only want to know the fruit weight, but they also need to know how fast the fruit is growing at a certain time. It is in the application, the function represent the cumulative fruit weight over time, while the derivative represent the instantaneous growth rate in gram per week. To model the fruit growth, I use the logistic growth model because pineapple growth follow a sinusoidal or S-shaped curve. At the beginning, the fruit grows slowly, then rapidly during the middle stage, and finally slow down again when approaching maturity. The derivative formula help identify the point where the fruit experience the maximum growth rate. This point is called the stage. Farmer can apply potassium-rich fertilizer and maintain proper irrigation to maximize fruit yield and quality. The application also use materialistic Malaysia agricultural reference from MARDI crops production guideline and Malaysian Pineapple Industry Board LPNM. Next, I will explain the interactive graph. This graph display two curves. The first one is fruit weight function, and the second one is the derivative graph. User can click on any point on the graph to analyze the derivative value at the specific week. For example, at week 11, the derivative value is around 140 gram per week. That means the pineapple is growing at its fastest rate during that time. The system also provide a simple explanation in layman terms so users can understand the agricultural meaning behind the mathematical value. For example, they recommend applying potassium foliar spray during peak growth to improve fruit expansion and juice storage. In addition, the application contain adjustable parameter such as fertilizer potency and environment factor. By changing this value, users can observe how growth pattern and derivative change under different farming condition. Overall, this project show how calculus, especially derivative, can be applied in real Malaysian bioscience and agrotechnology situation. Under the crops, it help farmer and student understand crop growth scientifically and support better agricultural decision making. That's all from me.
My name is Nuraiza Zahira. I will introduce you to poultry text mind an active simulator designed for modern Malaysian animal husbandry. In this presentation, we will explore how advanced biocalculus and environmental modeling can help poultry farmer manage heat stress, optimize feed efficiency, and maximize profitability in our tropical climate. Malaysia tropical climate. In standard traditional open house condition, temperature easily soar to between 32 Celsius and 34 Celsius. Under this severe heat stress, broiler eat less, suffer string growth and experience higher mortality rates. To combat this, modern Malaysian farm implement climate control closed house system. By maintaining temperature between 24 Celsius and 28 Celsius using evaporative cooling fans, we can drastically optimize poultry health and performance. But managing this risk require precise data. To manage this operation scientifically, tech, tech-savvy agricultural specialists rely on the compass growth curve, denoted here as FX. This function yields the cumulative mass of the broiler in kilogram on day X. However, looking at cumulative weight isn't enough. We need to track the rate of growth by taking the instantaneous first derivative fx. We find the average daily gain ADG. Calculating this derivative allows farmer to determine the exact peak of feed conversion efficiency, precisely time dietary transition, and pinpoint the ideal market weight harvest window. Our interactive web application simulates these dynamics specifically for the Cook 500 broiler, a standard genetic profile used widely in Malaysia. The application used as a base dataset beginning with a standard 42 gram day 0 cheat weight. The active mathematical content built into the model, asymptote A, scaling B, and grossly dynamically adjust based on environmental variable. This allows the user to see the immediate mathematical impact of environmental change on the animal biological. What makes the poultry tax tool highly practical are its interactive results. User can toggle between an optimal closed house environment and a heat stress open house environment by sliding the temperature up or down or manipulating the dietary nutrient density. User can immediately observe how a 2 Celsius spike in temperature or a drop in feed quality alter the derivative growth curve of the flock. It brings biocalculus to life for farm manager. Why does this matter? Because this data point translate directly into veterinary and management action. The simulator calculate that under optimal condition, the peak performance day happen at exactly day 23. Knowing this allows manager to change feed formulation from starter to finisher exactly when the bird metabolism demands it. Furthermore, it highlights the critical harvest window between day 35 and 42 to achieve an optimal feed conversion ratio (FCR). Under heat stress, this window shifts drastically, signaling an operational warning to the farmer. The predictive model in poultry taxonomy are not just theoretical guesswork. They are grounded in rigorous localized data. The underlying algorithm is verified against technical report from the Maldi Poultry Division. In conclusion, poultry taxonomy serves as a vital bridge between mathematical modeling and tropical animal husbandry. Create specifically for Malaysian agricultural curriculums and modern farm specialists, it proves that by understanding the derivative of growth, we can better manage heat stress, improve animal welfare, and drive data-backed precision farming. Thank you.
Okay, that's all for, from our group. In conclusion, derivatives are very useful in bioscience because they help us understand the rate of growth in agriculture system. By using calculus, researchers and farmers can monitor crop development, improve management strategies, and increase productivity in Malaysia. This project also shows that mathematics is not only theory, but can be applied in real life bioscience problem. That's all from our group. Thank you.